Now, let us notify nodes here. Okay, you can say nodes or the pivot points. Now, this is of ternary link. Okay, this is of ternary link. So now let us mark here names here. This is what link 1, link 2, link 1, link 2. Now let us take this as a link 3, link 4, link 5, link 6, 7, and 8 here. Okay, 7 and 8. Now, if you consider the links 6, 7, and 8, so now these are going to form a ternary joint here. These are going to form a ternary joint. You can say this ternary joint as a double pair. Okay, double pair. That means so 6 and 8 is a one pair, and 8 and 7 is a one more pair. Okay. Now, if you consider the number of pairs which are going to get to find out the degrees of freedom, so based on the Kutzbach's relations, so now let us find out the degrees of freedom here. Okay. So the DOF, okay, for such a link H, for such a linkage, so for such a linkage, so based on the Kutzbach relations, okay, now this is what 3 n minus 1 minus 2p1. Okay, now let us note down how many number of links you have here. How many number of links you have? Just count how many number of links you have. Okay, so now we have 8 number of links here. Okay, next you count down how many number of pairs have a 1 degrees of freedom. Okay, how many number of pairs having a 1 degrees of freedom? Can you count? Now, this is what ternary. This is what one pair. It has a 1 degrees of freedom, and that is out only turning. Okay, right? This is also 1, 1, 1, 1, 1, 1, 1, 1. But here it has a 2. Okay, but here it is a 2. So now let us mark here. This is what 1. Okay, this is one more. So now it has a double. Okay, it has a double, and you have one more here also, right? Now just to count down how many number of pairs you got: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so P1 equal to how much here? 10. So let us substitute. So 3, 8 minus 1 minus 2 into 10. So now find out how many degrees of freedom you got now. Right? You got 1 degrees of freedom. Okay. So what it shows that, what it shows, so the number of ternary or quaternary links in a chain can be reduced by providing double joints also. Okay. So if it is an ternary, okay, if it has a ternary or quaternary links, or joints. Okay, so can be reduced can be reduced by providing double joints also. Okay, right. So what I've done? I've done this ternary joint and a combination of binary joints to an pair, double pair. Okay, so pair means it has to be combination of what? Two elements. It has to be combination of two elements, right? Okay. No. So again, some methods have been reduced the equation which is used to find out the degrees of freedom based on the number of loops which is going to form in an kinematic chain, which are going to form in a kinematic chain. Let us look out here. Okay. So the following empirical relations is going to be formed based on the number of joints in a linkage. Okay. So when the number of links and the number of loops in a kinematic chains are known. Okay. So how it is? So another author has derived one more relation. Okay. So finding out the degrees of freedom. Okay. So when you know number of links or linkages in a kinematic chain, and number of loops also. Number of loops also. Right. So now this relation is only valid for linkages which have a turning pairs. Okay. Which have a turning pairs. If it is a sliding pair, then this is not feasible. Okay. So now degrees of freedom can be calculated based on the number of loops and number of links by using this relation. Okay. And the number of pairs can also be calculated by using this relation. Right. So now where n stands for number of links or linkages. Okay. So L stands for number of loops it is going to form. Okay. Number of loops it is going to form. Okay. Now number of loops it's going to form in a chain or linkage. Okay. Now how the number of loops are to be find out? How the number of loops are to be find out? Okay. So for example, now if we take a 4 bar or a chain which has an 4 elements, element 1, 2, 3, and 4. Right. So how many loops have been formed here? It is formed only one loop. Okay. It has formed only one loop. Now L equal to how much? 1. Okay. Now how many number of elements we have now? How many number of elements we have now? ಎಷ್ಟು elements are 6 seven. If it has 4 elements, okay. Now, how many number of pairs you have? P1 equal to 4. Okay. So now let us find out whether you are going to get the desired equations. That is what finding out the number of ಇನ್ನೂ join ಆಗತ್ತಾರಲ್ಲೋ. Okay. Now let us go for first equation. Okay. So if we substitute loops means it is in continuity. Okay. It is in continuity. Right. Now let us go for using this equation. So now degrees of freedom, we have 1 degrees of freedom for this. N equal to 4, right? Minus 2 into 1, okay, plus 1. Now you find out how many degrees of freedom you are going to get. 4 minus 3, 1 degrees of freedom, right? Clear. Next. So let us find out whether you are going to get number of pairs of 1 degrees of freedom 4 or not. Now how many number of links you have? You have 4 links here, okay? So plus L is how much? L is how much? Loop ಎಷ್ಟದ 1 minus 1, okay, so now this is equal to 4, right? You got a 4 here, you got a 4, and degrees of freedom as a 1, right? Suppose if the number of elements and the number of pairs and degrees of freedom are to be formed, okay, so sometimes you may get the linkage or a chainage as in superstructure, okay, or an simply structure. So now you got three relations here. So one is so author name is not here. Now this is what the relation to find out the degrees of freedom based on the number of loops and number of links. Okay. Earlier two relations. One is Gruebler's, another one is Kutzbach. Gruebler relations is holds with addition of number of pairs which have 2 degrees of freedom. Okay, and Kutzbach only holds for a number of degrees of freedom which has only one. Okay, clear. Now let's go for one more criteria here, that is what finding out the redundant degrees of freedom. Okay, finding out redundant degrees of freedom. So you got an redundant links. Redundant links are those which are not going to affect any relative motion of the component or any relative motion of the links. They will just work out as a support. Okay. On that cases, for analysis of degrees of freedom, you need to neglect it. You need to neglect it. Okay. So now let us go for one more bit here. That is what redundant degrees of freedom. Okay? Now, so let us consider a combination of lower pair and higher pair linkage or mechanism here. Okay. Have we made a discussion about this one? No, this is what I can. This is what I can. Okay. Right. Now, now let us number the links here. Okay. So number the links. Now this is what a fixed. Let us go for first link. Okay. So now this is a cam. This is what a second link. This is a roller, third link, and a connecting bar. There is a fourth link. Okay. Now, if you consider, okay, if you consider some of the elements are going to take a motion, okay, without causing any motion to the others, or translation, or either maybe rotational motion to the others. For example, for example, if you consider the roller, if you consider the roller, so roller is going to rotate about its axis itself. Okay, so the rotation of this one is not going to affect the oscillation of this fourth link. Okay, so it is going to rotate itself. Okay, it is going to rotate itself, but the effect of oscillation to this link 4 is obtained by the cam profile, is obtained by the cam profile. So on that cases, the roller becomes a redundant degree of freedom link. Okay, redundant degree of freedom link. So that means, just read the meaning here. So one or more links of a mechanism can be moved without causing any motion to the rest of the links of the mechanism. Okay. So as it takes rotation, it is not going to cause any motion to the other links. Okay. Such a link is said to have a redundant degree of freedom. Okay. This is called as redundant degree of freedom. Okay. Now, so before going to find out the degrees of freedom, so it is necessary to find out, or it is necessary to recognize the elements of which have a redundant degree of freedom for analysis of degrees of freedom. Okay. Now, in such cases, so the relation to find out the degrees of freedom is going to be obtained based on Gruebler's relations. Based on Gruebler's relations. Okay. So now, what is a redundant degree of freedom? Is say, so an element, motion of an element. Okay. So it does not going to cause any motion to the rest of the links of the mechanism. Okay. Such link is said to have a redundant degree of freedom. Okay. So now, as I said, so to find out, before going to find out the degrees of freedom for such linkages, it is necessary to find out, or it is necessary to find out the elements which are going to cause redundant degrees of freedom before substituting into the equation. It is not finding out the degrees of freedom. Okay. Now, in case of mechanism, okay, in case of a mechanism, so possessing some redundant degree of freedom, okay, some redundant degree of freedom. Okay. So the effective degree of freedom is given by the effective degree of freedom is given by F equal to 3n minus 1 minus 2p1 minus 1p2 minus Fr. Okay. Fr stands for the elements or linkage. So those have a redundant degrees of freedom. Okay. redundant degrees of freedom, right? Now, so F4 means what? F4 equal to, okay, number of redundant degrees of freedom. Okay? Number of redundant degree of freedom, right? Clear? Okay? So you have one more diagram, or you have one more example. So where you have got a redundant linkage, okay, or redundant links which are not going to cause any effect on the mechanism motion. Okay, mechanism motion. Okay, so if you consider this is the first link, second, third, and fourth link. Okay, this is the fifth link. Now in this case, you can neglect link 3, link 4, or link 2. If you remove link 3, it's going to give the perfect mechanism. Okay. Suppose if you remove link 2, 3, 4, 1, 5 are going to give the perfect mechanism. So in this case, so the effect is neglected. If the effect is neglected or it does not give any effect to the mechanism, on that cases you need to treat it as an redundant link. You need to consider it as an redundant link. Right. Now this is what? Redundant link. Clear? Okay. Now let us go for analysis of this diagram itself. Okay, this diagram itself. Now let us go for finding out the number of degrees based on the Gruebler's criteria. Okay, so now how many number of pairs you have here? Let us go for first number of links. How many number of links you have here? ಎಷ್ಟು total number of links ಎಷ್ಟಿದಾವ? Someone reply. Board ಮೇಲೆ ಬರ್ದೇನೆ already. Hello. How many number of links you have? You have 4. Right. Oh, no. So let us go for number of pairs which have only 1 degrees of freedom. Okay, only 1 degrees of freedom. Okay, so now it has a 1 degrees of freedom here. Okay, so it has a 1 degrees of freedom here. Okay, so it has 1 degrees of freedom. But now these pairs are a lower pairs here. These pairs are a lower pairs. So based on the definition of lower pair, so the lower pair is going to get only 1 degrees of freedom, right? 1 degrees of freedom. So now coming to the higher pair here. Now we are going to get a point contact or line contact here. This is what? Higher pair. So now this higher pair can be treated as equivalent to the 2 degrees of freedom. Equivalent to the 2 degrees of freedom. I think in some classification of the, yes, you've got a one meaning here. So the higher pair can be treated to an equivalent to the 2 degrees of freedom. Okay. So now this is what? 2 degrees of freedom. That means this is a pair which has a 2 degrees of freedom. Okay, it is a 1. That means so P2 equal to 1. So P1 equal to 3, P2 equal to 1. Now, how many number of links are here which have a freedom? It has a 1, right? It has a 1. Now, let us substitute in this modified Gruebler's relations. So, what do we get? Now f equal to, okay, so 3n minus 1 minus 2p1 minus 1p2 minus fr. Now substitute all values, find out what is the value of f1 here quickly. So 3, 4 minus 1 minus 2, p1 is 3 minus 1 minus 1. You got 1 degrees of freedom? Okay. I think the concept are clear. So what is a redundant link? What is the redundant degree of freedom and Gruebler's relations, modified Gruebler relations, considering the effect of redundant degrees of freedom, Kutzbach relations, one more relations based on the number of loops and number of links. Okay. Now let us go for some examples here. Let us go for some examples. Okay. Now, so for the kinematic linkage shown below, okay, for the kinematic linkages shown below, compute the following. Shown below, compute the following. Right? One is number of binary links. Okay. Second one, number of ternary links. Number of other links. Okay. Other links. That means quaternary and etc. Okay. And next, number of total links. Number of loops. Okay. Number of loops. Number of joints or pairs. Last one, number of degrees of freedom. Okay. Number of degrees of freedom. Okay. Now we'll draw the diagram one by one. We just try to find out all the bits which are specified in a question. Okay. So please note on this diagram. You quickly note on this diagram. Okay, now find out how many number of links we have here. First, we'll go for total number of binary links. Someone give the answer. How many total number of binary links are here? Okay, let us go for writing one by one. Okay. Now let us mark here or number the links here. Now this is what 2, 3, 4, 5. This is what 6, 7. Okay. You have got 7 links. Okay. Now 3, 4, 7, 5. These are binary links or ternary links? Okay. Let us go for first binary links here. Okay. So number of binary links here it is 4. Okay. Now what they asked? Now binary link is over. Okay. What they asked to find out the number of ternary links. Okay. Now we find out how many number of ternary links here. Huh? Sorry, you missed one more here. This has to be noted. Okay. Eighth one. So number of ternary links. Here it is also 4. Right. So is there any link which is of a quaternary nature and a pentanary nature? Other links. Does it have any other links except binary and ternary where it is a pentanary link? Pentanary link means it has to be hashed. Example, if it has a link here, okay, now this has to be hashed. Hatching means it is just like a rigid one. Okay, now we don't have this type of linkage here. You have this is a binary link. Okay, this is a binary link, right? So link is different. Okay, and the pair is different, and joint is also different. Okay, now total number of links. How many total number of links here? Okay, now coming to the number of loops here. So how many number of loops you have? How many number of loops you have? Just think about it. Loop means what? Just give me example. Loop means what? Continuity. Okay, check out continuity of the links which are related to each other. which are related to each other, which are connected to one to another. Okay. ಹೇಳ್ರಿ ಆನ್ಸರ್ ಹೇಳ್ರಿ ಅದು ಆನ್ಸರ್ ರೈಟ್ ಇರಲಿ ಕರೆಕ್ಟ್ ಇರಲಿ ತಪ್ಪು ಇರಲಿ ಆಮೇಲೆ ವಿಚಾರ ಮಾಡೋಣ. ಫಸ್ಟ್ ಯು ಗಿವ್ ದ ಆನ್ಸರ್. Number of loops are 4. Number of loops are 4. Is it correct answer or wrong? Let us check here. Okay. Let us check. Now link 1, 5, 6 is a one loop. Okay. One loop. Link 1, 2, 8, 7, 6 is one loop. Okay. Link 4, 6, 7, 8 is a one loop. Okay. Link 8, 2, 3 is a one loop. Right. Now you got an 4 loops here. Okay. This one using ice, you should. And don't say that the linkage is there. You can connect here entirely. No, it should form a closed loop. It should form a closed loop. Okay. So now let us go for counting out the number of pairs which have an binary joints here, which have a binary joint. So now can you find out binary joints? You can just count binary joints. ಎಷ್ಟು ಬರ್ತವೆ binary joints? No, this is one binary joint here. Okay, this is also binary joint. This is binary joint. This is two binary joints because 8 3 4 8. Okay, it has two binary joints. Okay, next 5 6. Here also it is a two binary joints. Okay, this is one binary joint. This is one binary joint. This is one binary joint. And this is one binary joint. Now you somewhere left. Now let us count 1 2 3 4 5 6 7 8 9 10 11. Okay, so you have how many number of binary joints here? 11. Okay, now let us find out whether this is right or wrong based on the number of loops and number of elements. Okay, number of loops and number of elements. So that is what using this relation. That is what using this relation. Okay, now so P1 equal to n in bracket L minus 1. Is it right equation? Okay, n plus L minus 1. Okay, so now number of elements are total number of elements are 8. Okay, loops are 4 minus 1. You got 11 here. Okay, you got 11. Now this is the correct answer, right? Now number of pairs are over. Number of pairs are over. Next is number of degrees of freedom. Okay, next is number of degrees of freedom. So now we can find out number of degrees of freedom. So based on the relation, Kutzbach relations, or you can find out based on the number of loops and the number of elements here. Okay. So now let us go for degrees of freedom based on the Kutzbach relation. Okay. Now you have 3. Number of elements are 8 minus 2 into 11. Okay. So 3, 7, 21 minus 22 minus 1. So now what type of structure it is? So as it is a negative degrees of freedom, this is what? Superstructure. This is what? Superstructure, and it does not have any mechanisms within it. Okay, mechanisms within it. Now Let us go for next diagram. Okay, let us go for next diagram. Okay, now we calculate. Now we calculate number of binary elements, number of ternary elements, other elements, total number of links, total number of loops. Okay, we just find out. डबल एक्स कैसे आते थे ನಂದ ಕ್ಲಾಸ್ ನಡತ್ತಪ್ಪ ಈಗ number of links now we calculate. Okay, fixed link 1. Okay, ternary link 2, binary link 3, binary link 4, ternary link 5, ternary link 7, binary link 6, ternary link 6, binary link 7, binary link 8. Okay, now we calculate number of binary links, number of ternary links, total number of links, total number of loops, number of pairs, and degrees of freedom. We quickly calculate. Okay, how many number of binary links? Okay, number of binary links are 4. Good. Now, how many number of ternary links? Next to the ternary link 3. Okay. Now, total number of links 7. Now, how many number of loops we have here? Hmm? 1. You consider link 1 also. Okay. You consider link 1 also. Okay. So now it has a 3 loops here. Okay. Now I will link the connectivity 1, 7, 8. Okay. Sorry. 1, 7, 5, 6, 8, 1. Okay. Next. 1, 8, 6, 2, 1. Okay. Next. It has 2, 3, 4, 5, 6, 2. Right? It has a 3 loops. It has a 3 loops. Clear? Okay. So next you find out number of pairs. You can go for counting. You can go for counting. Uh, Number of pairs now we calculate. Hey, who is this? To be a 20 ME 416, you just mute yourself. Okay. Now voice is clear. ನೀವು ಮ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕಾಗಿಂದಾಗ ನಾನ್ ಮಾತಾಡಿದ ನಿಮ್ಮಲ್ಲಿ ಪ್ರತಿಧ್ವನಿ ಆಗಿ ಮತ್ತೆ ಇನ್ನೊಬ್ಬರದಲ್ಲೇ ಸೈಕಲ್ ಆಗಿಬಿಡುತ್ತದ ವಾಯ್ಸ್ ಅದು. ಹಾ, ಓಕೆ. ನಾವು ಈಗ ಫೈಂಡ್ ಔಟ್ P1. Now this is what one binary, one binary, one binary, one binary, one binary. Okay. Now how many total number of pairs you have here? ಎಷ್ಟದು? 3, 4, 5, 10 ಅದುವಾ? 10. Okay, 10. Now this is my counting. This is what by counting. So based on the relation, this is what n is how much here? 7. Okay, n is 7. Okay, plus. You just check it. How many number of loops you have? A linkage is just the note. 8 ಅದಾವಲ್ಲ ಲಿಂಕ್. ಟೋಟಲ್ ಲಿಂಕ್ 8 ಅದಾವಲ್ಲ. ಟೋಟಲ್ ಲಿಂಕ್ 8 ಅದಾವ, ಹೌದಾ? ಫಿಕ್ಸ್ಡ್ ಲಿಂಕ್ ಬಿಟ್ರಲ್ಲ 8. Okay, 8, 3 minus 1, this is equal to 10, right? This is equal to 10, right? Now we find out degrees of freedom. So this is what 3n minus 1 minus 2p1. Okay, 8 minus 1, 2 into 10, you got 1 degrees of freedom. Okay, you got 1 degrees of freedom. So that means this linkage has a constrained motion when one of the 7 moving links is driven by an external source. This is what a constrained motion. Okay, so everything is going to be rotate about a fixed pivot point, right? Okay, so now I will stop here.